Okay, just to reiterate, you can also record or read from these Excel tables by specifying read table as an Excel sheet. You can pick the range in terms of rows and columns, and you can read the variable names or not. You can treat things if they're whatever string you want as empty. You can skip values, and if there are missing values, like a blank thing in your spreadsheet, then it puts in certain numbers. And you'll try this, I believe, with your homework this week. So now we'll talk about saving and reading matrices, something a little more simple, actually. We have these matrices in our memory. We might want to save the matrix. We might want to save files with our data or with text. And so we can use this save command and save this matrix in the Matlab format. So let's say that in our workspace, we clear everything here, and we say my world equals is beautiful. Your world is 0. And then we say save worlds. Now we'll create, let's get rid of these ones that were already in there. And we'll save worlds, and you'll see that we'll create this .mat file that has the variables that we have in our workspace in it. You can see down here what's in the worlds.mat file. So then we could even save it as name, for instance, or any other word we pick, and it will save it as a mat file with that name. Let's check what that does. So we can clear all, and we have nothing in our workspace, and then we can type in load worlds. And you can see now these variables are in the workspace. We could have also just dragged this file into our workspace to load those in. And you can see the function that it calls to do that. You could save certain variables, but not all of them. So you might want to save just 1 or 2 variables. You could add stuff into an existing variable. So you could save an existing file, but you want to append this variable to it. You could even use the star command to pick a whole bunch of variables that all start with some letter, say the letter A. So save all the variables starting with an A in a file called avariables.mat. So you could load all the variables. You could load certain variables from the matrix. Say just variables 1 and 2. There's more powerful load options later in the semester that we'll talk about. So reading text, you might already know, is different from reading numbers, but you can transform one into the other. So if you have a bunch of numbers but you want to write them out as strings onto the screen, you can transform numbers into strings with these kind of commands, even whole matrices into strings. You can also convert them into arrays of characters. You can also do the opposite. You can have a string as a number. So say you have test is equal to 567. Oops. Test is equal to 567, a string that someone's typed in. You can say string to num of test, and you'll get back an actual number, 567. Now we'll talk a little bit changing pace about functions. Functions are other kinds of scripts that you can push values into and give back outputs. So a lot of the things that we've been using, like rand 1001, is a function that you put as inputs the number of items and the rows and columns that you want, say. And it gives us output some value that you can assign to test. So functions can take an input, like passing variables to it, and then they can return outputs. All the variables inside the function are internal. They don't leave the function, and you never get to see them unless you peek inside. The name of the function and the file in which it's contained have to be the same, and you'll see what I mean in a second. So we're just going to start a new script. We'll say edit name of function. And so at the top of the M file, that would also be called name of function.m. We type in function, we type in the output of that function, the name of the function, and the variables that we want to give it to do its job. This is just a generic way of saying it. And then you write your program down here, and your program can then use those two variables that you pass to it. So you can add the two variables together, and then you might say your output is equal to test. So this function that we haven't really named anything useful yet could take these two numbers that you give it and add them together, and as output give you the sum. That's a very simple example that sum probably already does, but more flexibly. So function output, name of function, pass variable 1 and 2. Output will hold the value that will be returned by the function. They can be any type. You can give it any name you want as an output. The two pass variables are arguments of the function. You can pass as many arguments as you like into a function. These are values. Passing variables are values that constrain the execution of a function. For example, you might have a function called draw square, and you might want to indicate that you want it to draw at some leftward place and at some place from the top, and you want it to be a certain size. And where you want it to start on the left and where you want to start at the top and the size are going to be values you would need to draw a square, and it will then draw the square with those values. And we'll talk more about drawing next class. In your code, then you can, as you'll see what I did here, you can refer to those pass variables and do math on them as you want, leading up to the output that you need. And it doesn't have to be output as a function. It could also be, say, to display output on the screen. So just to show you what this does now, we can say test is equal to name of function, or let's say foo is equal to name of function, and we want it to add the values 2 and 3. And we get back that foo is equal to 5. We've also seen that it prints 5 there. So if we don't even specify an output, we get the same thing. And if we turn off this display, then we just get back that number 5. We could have taken the output off of here and just have it display as another option. And so there would be no, yes there would. So now we can say name of function 2, 3, and it will just print 5 there every time we call it. When you call a function in your program, you can specify values themselves, or you can pass it variables that already have values. So let's make a little function here, maybe our first function. And let's call it scramble. So we'll say edit scramble.m. We'll make a new function, and we'll say function ardo equals scramble word. So when we give it a word, it'll scramble and output something. We say this is our help function. This explains our code. Now down here, we can have a bunch of different variables that use that input word. So we want to know how long the word is first, the name size. Then we say our new order equals rand perm name size, random permutation of those values. And the output we want to give, the scrambled word, is our word with the new order. And now we can save it. That should be everything. The output is the scrambled word. So it's very similar to the function that you already made, except now we're treating it as a function. We can give it a word and output something out instead of just printing it out and asking the user for a word. So now we can use our new function. So we can say clear all, close all, CLC, and we can then say my name equals Kyle, new name equals scramble my name. And now when we press enter, new name will be a scrambled version of my name. We can do that over and over again. And it'll give us different scrambled versions. We could output that so that it doesn't print to the screen, but see that the new name each time is a different value up here in the workspace. So my name is passing the value of my name to the function. We didn't use the word word. Notice how the function itself has word in it here. What is what you call and what you give it. We don't have to use that word. We can use any name. And then once it gets inside the function, it treats that as the variable called word here. Word is internal to the function. We don't have to assign we don't have to assign an output. We can just output and then we'll assign it to answer. And we don't even need a variable here. We could have just typed in the name itself. So you can see how flexible this is becoming. We could even say scramble Kyle. It's treating it as a string this way. We could say scramble my name. Notice how it didn't really do what we expected. It's treating my name as a string and not using the variable my name up here. If the input's a string, Matlab allows you to call the function without quotes and without parentheses. Next, we're going to talk about just a couple other types of variables. So we'll actually finish off this last couple slides about variables in a fifth and final video for this week. So check out the last video to learn about global and persistent variables.